Alright, we're going to look at lesson 3.2, solving systems of linear equations algebraically. The learning goal: to solve systems of linear equations by two methods, the addition method and the substitution method. I'll require that you are proficient in both of these. You'll be tested on both, so after this section, though, if you use this again, and we will use this again in other parts of the course, you'll be given the option to use either method, but we will be tested on both. Okay, the addition method, sometimes called the linear combination method and also called the elimination method. You'll hear me use that word. Let's look at example number 1. Solve the systems using the addition method. Okay, when we use the addition method, what we're hoping for is to add the equations, and one of the variables, whether it be the x or the y, we hope that they add out or eliminate. Well, as you look at this first example and look at the y's, the coefficients in front of the y's are positive 1 and negative 1. Now, opposites add to be 0, and when we have opposites in front of the variable, we say that they will eliminate when we add them. So this problem is ready to add, so we'll go ahead and add these two equations. To add two equations, you add the left-hand side of the equal sign to the left-hand side and the right to the right. So adding the like terms over here, 2x and negative 3x is negative x, and the y's, positive 1 and negative 1, is plus 0y. No need to write that. Equals, and on this side we have negative 3. We need to solve for x, and the number in front of x right now is negative 1. We need to be positive 1. We divide both sides by negative 1, and we get x is equal to negative over negative is positive, 3 over 1 is 3. Okay, now just like in the last section, we're looking for the same kinds of solutions in section 3.1. We solved systems by graphing, and we found the point of intersection, or points of intersection. And here we get the same kind of answer. So what we know so far is that 3 is our x-coordinate of the ordered pair that we're looking for. To find the y-coordinate, we take our x answer and plug it into either one of the two equations in the system. Let's pick the top equation and plug 3 in for x. 2 times 3 plus y equals 7. 6 plus y equals 7. Solving for y, we subtract 6 from both sides. We get y is equal to 1, the other coordinate of our ordered pair, and the solution to this system is 3, 1. Now, reflecting back on the last lesson, if we were to graph both of these on the same xy coordinate plane, these lines would intersect at 3, 1. Okay, you go ahead and try this one, and I'll come back in a second. Alright, that should be time enough for you to solve it. Looking at this system, and you'll notice that the x is already to add out. So that's sort of like a gift. I call this the birthday problem because you get gifts on your birthday. The fact that the coefficients of x are already opposites, and that's what we're trying, that's what we look for, is to have opposites. The x add out, negative 2y and y add up to be negative y, and on the right hand side we get 2. We divide by negative 1, and we get y is equal to negative 2. Plugging that into the bottom equation, negative x plus parentheses negative 2 equals negative 4. Make that look like an x. Solving for the double signs, minus a negative is minus 2 equals negative 4. Solving for x, add 2 to both sides. We get negative x is equal to a negative 2. We divide by negative 1, and x is equal to positive 2. So the solution to this system is 2, negative 2. Okay, next example. Here, when we look at this system, the directions are the same, solved by adding. We don't see any gifts or none of the pairs of coefficients or opposites already, so what we have to do is create opposites. Well, the first thing you want to do, if you don't already have opposites, is to look to see if one coefficient goes into the other one. In other words, in the x's, will 2 go into 4? Yes, it will. So the simplest thing for us to do would be to create a 4 and a negative 4 in front of the x's. So we'll choose to eliminate the x's here. And for these to eliminate, then this number would have to be the opposite of 4. This would have to be negative 4. To make this into a negative 4, I can do that by multiplying by negative 2. So I'll choose to multiply by negative 2, but to do that I have to multiply everything in the equation, not just the x, but the whole equation. Every term in the equation has to be multiplied by negative 2. So I put it in brackets, put times negative 2 on the outside because I want to create a negative 4, which is the opposite of the 4. Multiplying negative 2 times 2x gives me negative 4x, and we'll write it underneath this bottom equation. Negative 2 times negative 4y is positive 8y. Negative 2 times 13 is negative 26. And we add. The x's go out or eliminate as we planned by adding. Negative 5y and 8y is positive 3y equals, and this is going to be negative 18. Solving for y, we divide by 3. And 3 over 3 is 1, or 1y is simply y. Negative 18 divided by 3 is negative 6. Okay? So in our solution, we know the y-coordinate is negative 6. Now we're going to find the x. Pick either one of these equations. It doesn't matter. Let's take the top one. 2x minus 4, substituting negative 6 for y, equals 13. 2x, negative times negative is positive. 4 times 6 is 24. Solving for y, we get rid of the constant first. We subtract 24 from both sides. 2x is equal to negative 11. I see we're not going to have an integer answer, but that's okay. We don't always get integer answers in Algebra 2, and we are satisfied with 11 over 2. Typically, we do not reduce improper fractions but to mixed numbers, but we do reduce them to the lowest term. So we have negative 11 halves for our answer. Okay, so that's the solution, negative 11 halves, negative 6, that ordered pair. You try this one. Okay. First step would have been to look to see which variable you want to eliminate. Since 2 doesn't go into 3, I would check the y's, and in the y's 2 does go into 6 evenly, so we'll set this up so that the y's eliminate. Of course, we have to have opposites, and I can already see that I have opposite signs, so I don't have to concern myself with the sign, but this number here must be the opposite of negative 6. I need to create a positive 6 here, and the only way I have to create it is by multiplying the entire equation times something. So it'll be the entire equation times 3. 3 times 2 will be 6. So positive 3 times negative 3 is going to be negative 9x. Positive 3 times positive 2y is 6y. And 3 times 10 is 30. And we add and we get negative 7x is equal to 49. And we divide by negative 7. And x is equal to negative 7. We take negative 7 and we plug it into either equation up here, and let's just pick the top one. It looks good. Negative 3 times negative 7 plus 2y equals 10. Negative times negative positive, 7 times 3, 21, plus 2y equals 10. Subtract 21 from both sides. 2y is equal to negative 11. And divide by 2, y is equal to negative 11 halves. Okay, let me check, make sure I did that correctly. Yeah, we had negative 11 halves in both answers, so our solution here is 2 negative 11 halves. Kind of odd, but that's the answer. Okay, let's move on to the next example. All right, example 3. Same instructions solved by the addition method. There are no gifts here, but so we look to see if one coefficient for a variable goes into the other. It's not going to happen in either case. At this point, the easiest way to do this, or the simplest way, is to think of these in terms of least common multiples for the coefficients. The least common multiple for 7 and 5 is going to be 35. The least common multiple for 12 and 8 will be 24. Since 24 is smaller than 35, I'll choose to set up the y's to eliminate so that they add out. So I'm going to have to multiply both equations by something, and I need to create a positive 24 and a negative 24 in front of the y's. I already have opposite signs, so I'll let this be the negative 24, but 12 would have to be multiplied by 2, and then 8 to become positive 24 would have to be multiplied by 3. Now I have to multiply the entire equations by those numbers. So 2 times 7x will give me 14x. 2 times negative 12, negative 24y. 2 times negative 22, negative 44. 3 times negative 5x is negative 15x. 3 times positive 8y is positive 24y. And 3 times 14, 42. So we add, we get negative x, and the y's add out just like we planned, and we have negative 2. Dividing by negative 1 to get x by itself, x is equal to 2. Plug that into either equation. Let's take the bottom one. Negative 5 times 2 plus 8y equals 14. Negative 10 plus 8y equals 14. Add 10 to both sides. 8y equals 24. We divide both sides by 8, and y is equal to 3. Solution to the system is the ordered pair 2, 3. Or if we were to graph these two, they would intersect at 2, 3. Okay, you try this one. Okay, let's work this one out. Looking at the x's, 6 doesn't go into 9, and the y's, 4 doesn't go into 5. I have to multiply both equations. I have to create the opposites. The least common multiple for 9 and 6 would be 36. The least common multiple for 4 and 5 would be 20. And so I'll choose the smaller one. I'll choose to eliminate y. So we're going to set it up so that there's opposites in front of the y. The only way for us to change anything is to change everything. We have to multiply the entire equation by something. To create our negative 20, I'll multiply by 4. To create the positive 20, I'll multiply this by 5. Everything times 4 in the top equation, and we get 36x minus 20y equals negative 28. And the bottom equation, negative 30x plus 20y equals 10. We add and we get 6x. The y's cancel or eliminate like we planned, equals negative 18. We divide by 6, and x is equal to negative 3. Plugging that into the top equation, 9 times negative 3 minus 5y equals negative 7. Negative 27 minus 5y equals negative 7. Add 27 to both sides. Negative 5y equals 20. And divide by negative 5. Y is equal to negative 4. Solution to the system, negative 3, negative 4. Okay, so each of the last several problems that we've done, we've come away with one solution. Now I want you to think back to section 3.1, and what we learned there was anytime you have a system, you have one of three possibilities of solutions. Either it can be one solution like we've had in the last three kinds of problems, but there's also a possibility of no solution or infinitely many solutions. So I want to talk to you about what those look like. So let's take a look at example 4. And let's try to eliminate something. So we can eliminate the y's. 2 goes into 4 evenly. So let's take this top equation and multiply by, for these to be opposites, this is going to have to be a positive 4 here. So to only get a positive 4, we multiply by a negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 2y is positive 4y. Negative 2 times 3 is negative 6. So our plan was to eliminate the y's. Now look what happens. 2 and negative 2x, that's 0x, so it zeroes out. I don't write anything. Negative 4 and positive 4y, that zeroes out. 0 plus 0 is 0. And then on this side I get 1. So I tried to eliminate the y's, but I eliminated the x's at the same time. So I lost both of my variables, and the resulting statement is a statement without variables. It's just numbers. Now what you need to do is look at the truth value of the remaining statement if you lose both your variables. Does 0 equal 1? No. This is a false statement. And if you lose both variables and you wind up with a false statement, you could probably guess, but the answer is no solution. This, if we were to graph these lines, these would turn out to be parallel lines. There would not be an intersection, but in algebraically, what parallel lines look like is you lose your variables and you get a false statement. So the answer is no solution. Okay, look at 5. Let's eliminate the, let's see, well, we're going to have to multiply both equations. Let's go for the y's and go with 50. So if I want 50y and negative 50y, I can make this the negative 50y by multiplying by 5. And this equation, I can make this a positive 50 by multiplying the whole equation by 2. And then 5 times 6x is 30x minus 50y equals 60. And on the bottom, negative 30x plus 50y equals negative 60. We had the equations, and both the x's and the y's add out, so that leaves us with 0 on this side. And 60 and negative 60 also add up to 0. And so we lose our variables, and we're left with a 0 equals 0, which is a true statement. And so that corresponds with infinitely many solutions. If we were to graph these, they would be the same line. Okay, infinitely many solutions if you lose your variable and get a true statement. Okay, couple for you to try. Go ahead and do these two. Okay, assuming you've had time to do that. In this first set, we'll eliminate the x's by multiplying the bottom equation by 2. That'll give us negative 6x plus 4y equals 14. Now let's pretend that this equation is not there and add these two together. That should not be in, that's just a rogue mark there. Don't pay any attention to that, please. Okay, so 6x and negative 6x is 0. Negative 4y and positive 4y is 0. 0 plus 0 is 0. 14 plus 14 is 28. False statement. Answer, no solution. And in this one, we'll multiply the bottom one times 3 to get the x's to eliminate. We get negative 9x plus 3y equals negative 15. Again, let's just pretend that's not there. 9x and negative 9x, we'll add the top and the bottom equation is 0. These 0 out, this side is 0. 15 and negative 15 is 0. A true statement. Infinitely many solutions. The two lines are the same if you graphed them. Okay. All right, so that does it for the addition, linear combination, elimination method, one of those three names. Let's take a look at the substitution method. Again, now you're going to be required to solve some by substitution, so that you'll have to learn both of these. When we leave this section and we're tested on this, you will have your option to pick the method that you want to use after that, but right now we have to learn both methods. Okay, with the substitution method, in this class, I'll never require that you do substitution unless the system has a 1, and by that I mean a 1 in front of one of the variables. So look at the coefficients, 3, 4, 2, and 1. It's the second equation that has a 1 in front of the x. So wherever the 1 is, you take that equation and you solve it for that variable. So I'll take x plus 2y equals 13, and I'll solve for x, the variable that has the 1 in front of it. Let's get the x by itself. So I think I have an error in this thing, and this should be a 2 right here. So I'm going to go back and correct that, make that a 2. I'm looking over here at the side, and I can see that I didn't type that in correctly. So take this out, and let's put a 2 there. Okay, so we're going to solve this for x. Subtract 2y, subtract 2y, and we get x is equal to negative 2y, positive 2. Okay, so after you solve the equation for a variable, you take the other equation that you didn't use, and where that variable is that you solve for, in this case it's x, the x in the second equation, I turn it into a parenthesis. So I write 3 parentheses plus 4y equals negative 4. Basically what I did is I created a place to substitute this into. So I'll take this over to here and I'll plug it into this first equation. So where the x was, I'm now going to put negative 2y plus 2. And I'm going to solve this equation, and it's going to tell me what y is. To solve it, though, I'll first have to distribute the 3. So let's do that. 3 times negative 2y is negative 6y. 3 times 2 is positive 6. Bring down the plus 4y equals negative 4. Combine like terms on this side. Negative 6y and positive 4y is negative 2y. Plus 6 equals negative 4. Rewriting that up here because I'm running out of room. Next step would be to subtract 6 from both sides. We'd get negative 2y equals negative 10. Solve for y, divide by negative 2. And y is equal to 5. All right, now, you know one coordinate is. Take this back up to what you did in the first step, where you solve that equation for x and plug 5 in to that equation for y. So this is what we get. So x is equal to negative 2 times 5 is negative 10 plus 2. X is equal to negative 8. So our solution to the system is negative 8, 5. Okay? And you go ahead and try this one. Okay, assuming you've done that. And we'll look through the system to find the 1. There's a 1 in front of the y in the second equation. So take the second equation and solve for y. Okay, let's do that. So we're going to subtract 3x from both sides. We get negative y equals negative 3x, and at positive 13, so I'll write plus 13. And then we take the equation that we didn't use in the first step, which is this one up here, and we put a parentheses in for the variable that we solved for. We solved for y, so the y becomes a parentheses. Basically, it's a place to put this. Take this and substitute it in. So where the y was, it now becomes negative 3x plus 13. We distribute the 2. It's not going to be positive, but it's going to be negative. Erase that. So we get minus 6x plus 26 equals negative 10. Combining like terms, 2x and negative 6x is negative 4x plus 26 equals negative 10. Bring that up here, rewriting it, running out of room on the bottom there. Subtract 26 from both sides. Negative 4x is equal to negative 36. Okay. And let's move that up here. Negative 4x is equal to negative 36. Divide by negative 4. X is equal to positive 9. Plug that in to wherever we solved for y. And I come back here and I look at this and I see a problem with this right here. We made a mistake here. We didn't solve for y. We stopped at negative y. Pardon me, but we're going to have to backtrack. Sorry about that. Okay. Let's take this out and take this out. We're going to have to back up to this set. Because this is not solved for y, we have to divide by negative 1. Everything's divided by negative 1 here. And we get y is equal to positive 3x minus 13. Now that's what we should have substituted in here. Let's go back and do that. 3x minus 13. So 2x plus distribute the 2. 6x minus 26 equals negative 10. Collect like terms. 8x minus 26 equals negative 10. Copy that over again here. Getting kind of cramped on space. Add 26 to both sides. 8x equals 16. Divide by 8. X is equal to 2. Now take x is equal to 2 and plug it back into where we solved for y. And this becomes y equals 3 times 2 minus 13. 6 minus 13. Y is equal to negative 7. Solution to the system is 2, negative 7. Okay, well that concludes this lesson. I'll go ahead and make the assignment after the video is over.